Hey there, fellas. Alright, so the winter's rolling in, and two-wheel drive cars are going to struggle, especially rear drive, with setting off especially on an incline, where one of your wheels might start spinning. Constant headaches. Anyway, limited slip diffs are quite pricey. In the past, we've tried to make our own, but in this video, let's revisit the topic and attempt to make a design that's actually functional. There are some out there on the internet, but those don't really work all that well. And so let's get all hands on deck. We've got a big team. We'll try and come up with something that won't cost us anything, well, that we won't have to spend any money on, and that anybody will be able to make. Let's go. So on a car that's running a regular open differential, if I were to spin this wheel in reverse, so to speak, the other one is going to roll forward. And vice versa, of course. But when you've got a locking diff, the two wheels are going to rotate in the same direction. An open diff is not going to be preloaded whatsoever. So if I were to hold one of the wheels, hold that one, please. In that case, well, you can plainly see that I can easily and effortlessly get it to turn. That tells us there is no preload or rolling resistance at all. I'd say it's less than half a kilo even. Because of the friction inside the bearings, just the friction overall, I mean, yeah. So check this out, guys. What I've got here is a regular old open diff, and as I'm sure you know, the rotation is constantly being transferred to one wheel, the one that has an easier time rotating. And our objective would be to make sure that the torque is going to both wheels at once. And so these spider gears right here, obviously if we weld them up, both wheels are going to turn in sync, but we decided we won't go that route. And so the idea would be to introduce a bit of preload in between them, for them to want to rotate together. Now, there is one DIY deal out there where you machine some sleeves, fit a spring to push them out, and the friction is what creates the limited slip effect. That's where I suggest we start, because my explanations might not be painting a clear picture. But to give you a better understanding, let's take this apart, make those sleeves. Or they can be shims, we'll figure out how to do this as we go. And we'll just need to see how well this sort of setup works. The way I see it, it's the proper way to go. We're just gonna need to make some improvements. Right, let's do this. So these are all made of brass. Well, at least it says you're better off using brass. What's the brass going to rub against? The steel bit? The steel, yeah. And that means a lot of wear. Putting it together is only going to take an hour. We do need to machine the sleeves. Not a problem. We just need to do that. And this setup, my guess is that this is where it's at. This is the best way to go. The simplest for sure. Yeah, the simplest. And the simpler, the more reliable. However, this is not going to have enough bite. Won't be much preload. Yes, I guess we make it insane. To increase the friction, we can use stiffer springs. But the more force they exert, the greater the wear. Let's use this for a start, but we do have some better ideas. Okay, here we have the differential, and here's what's going on. We've removed the crown wheel, the pinion. I mean, the pinion is in the housing, the crown gear will bolt to this. But over here we have the spider gears, and when these aren't loaded, the two sides are going to rotate in different directions. But when you've done what we have in this case, we fitted a shim on each side, and put a spring in between them, it pushes the shims into the gears, transferring torque through itself. And I must say that there is now quite a bit of tension in these gears. As a result, they should at least transfer some amount of torque. Yeah, definitely. And to work out how effectively this is going to function, now we just, we throw everything together, replace that open diff, and attempt to move the wheels around. See how well this sort of LSD works. Now, I honestly don't think the spring will make for effective torque transfer, as it winds up in one direction and unwinds in the other. There will be some, but the efficacy of the whole thing, let's install it and see for ourselves. Check this out, our setup with the two shims and the spring is in. And when you just turn the prop shaft, both wheels are turning forward, but I'm not feeling any enormous force. I have no trouble holding this in place with my hand. And yeah, you know what? I don't think this is going to work. During a hard launch, or in case of wheel spin, I don't think we'll even feel anything. We'll just have the one wheel spinning freely. But then this was experimental. We just wanted to sort of feel this out. But now I suggest we make this system slightly more complex. And once we do, I expect that we'll feel, greater effect from this setup, more in line with what it's supposed to do. To achieve that, we need to make a couple of small sleeves. Let's do that and add them into the mix. Alright, so I am looking to make a sort of sleeve/spreader. It'll be placed in between the spider gears, but it's not an ordinary sleeve. We're going to give it additional bite. Nah, it's not a ratchet mechanism, it's more of a mechanical lock, I'd say. Or akin to, say, the way an impact screwdriver would work. You have a mechanism that exerts force, and that breaks away when there's too much force, allowing the counterpart to turn. And the idea is to increase that preload component for both of the wheels to turn. But if there is too much stress, we want one of them to be able to turn at a different rate from the other. Right, there's the idea. We don't know how to realize it, but whatever, we'll figure it out. Which spring do we fit? I was on the forums yesterday, and people use everything you can imagine. The ones for a lot are good for about 1.5 to 2 kilos of preload, but they degrade. I mean, over time they become softer. In theory, we could just fit a bunch of shims. I'd imagine the sleeve is gonna wear down. So while Vlad is making his sleeves that aren't gonna work anyway, I've decided to try a recipe of my own. The spider gear. Here I've got a sleeve. Right here we'll cut out 2 slots to accommodate both of the edges. You're better off making 4 of them. We'll be running 2 such sleeves, and in between them we'll fit a spring that's going to push them apart. And this setup should work, right? let's check the final drive. It is resisting though, right? Well, I am applying force. So check this out, this new setup should work, supposedly. Although, but then hey. Springs, no springs. I am feeling... No, there is some tension. Nice. Now this might have some potential even. Wanna try driving off the jack? It's not even trying to get moving. Not in the slightest. The only change is a crunching sound coming from the rear diff. Where does that bring us then?
Crap. Mega crap.
This setup does not work well. All we have is crunching in the rear diff. But let's go ahead and remove it and try that design that's recommended by the internet for setting up a DIY sort of limited slip differential. Make some sleeves also fit a spring. And yeah, let's try that out and see how it works. Let's go. So this sort of setup with these sleeves that are meant to limit the slip, it does have a certain drawback. We noticed that some people wrote that material needs to be removed from here, that you need to make a recess. Mind you, there won't be much preload as it is, and there's the issue that the two sleeves can overlap, due to the fact that this lovely axis narrows in this spot. And so as a result, once the sleeve gets to a certain point, once it makes it to that narrow spot, it starts to wobble around on the axis. That's what causes the aforementioned issue. I mean, this is a pretty thin wall as it is. The slightest misalignment and there you are. And so we've welded on some material to keep it from warping. Machined it down to the required diameter. And so now this sleeve is on there tightly. Yes, there is still a bit of movement, but it's not nearly as bad as it was. Right, let's continue making adjustments and piece everything together. Okay, we've got everything assembled, the parts are where they should be. And already I can tell you that... Why is this so tight? Perhaps it might be binding slightly. Now I think we should fit this to a car, spin the wheels, and go for a drive already. Like... Somebody out there parked their car very poorly. So check this out, we fitted the limited slip diff with the spring-loaded brass sleeves. And now let's see what happens. Alright, this is looking good. We have got two wheels turning in one direction. That tells us that we do have some preload now. Can you hold that one, please? I can't quite tell at which point... It is trying. Well, yes, it is. But this does seem to be working a bit weird. So until they break free, we have torque transfer. But once there's a bit of slip, the same effect isn't quite there anymore. Now, these sorts of results just won't do. It's not even about whether it'll drive off a jack. The question is, will it even spin both wheels when you're... Anyway, time for some drastic methods or measures, yeah? The most drastic way would be welding it, but we won't be doing that. Right, let's try to increase the grip level even further, with the use of that mechanical locking sort of device. In order to lock those spider gears, to keep them even firmer in place. Let's see what kind of options we have. We can cut off this much material from the teeth, like a millimeter. But we shouldn't go too far, because of the engagement. We can't do that because the shim can slip underneath one of the other ones and jam the entire diff. You will see that these are fully engaged, and if we set it in too deep, in that case, the teeth will interlock. Or rather, the teeth will catch the sleeve. This has 10 teeth. We'll remove material from every other one to get a sort of comb going. The sleeve is also going to have 5 teeth for both bits to grip each other. It's the same basic setup. We just made a few improvements. There is a tiny issue here. We have made the safety locking mechanism, cut out a sort of crown, and we did the same thing on the other side. And once we get everything assembled, the parts should interlock pretty well indeed. These two parts lock, torque is transferred through this bit further down the assembly. The spring is going to push them apart and into the other bits, and when the stress gets too high, I have no idea what the exact figure would be. We can't really calculate it, this being an experiment. But the spring should give in, the teeth will skip, then re-engage, and this limited slip differential of ours should work quite beautifully. Okay, we've installed the limited slip differential with the safety lock. And at this stage, we were very much expecting this to work well. The two wheels are in sync. Can you hold that one? Which way do I turn mine, though? Try forward. Forward, okay. What happened? You just rotated me. For real? Hold it tightly. What the fuck? And how are you supposed to measure the preload using a torque wrench? Let it go, please. Will you look at that? Why don't we check? If it's able to drive off the jack, that'll be just awesome. Now, there is a weakness here in that we've made the bits from metal, from a softer grade of steel that isn't forged, and ideally we would have preferred to do some thermal treatment, but we weren't able to, unfortunately. Also, I'm sure a lot of you we'll find out soon. This sort of setup should be good for an entire season of winter drifting. I've got my torque wrench, set it to 7 kilos. Check the preload. Yeah, it's more than that. 13 kilos. Alright, so now we know where the preload is at. The number is somewhere around 12 to 13 kilos, which is pretty good, I think. And now let's try and see how it behaves during a test drive. On the move, so to speak, let's go. Okay, we've got the car on a jack. We've also added a jack stand for good measure. It's under the axle. And you are not just pushing this car off of it. And now we test the limited slip diff. Will it be able to pass the test, or will it not? Engine is running. Here we go. Ooh, what's wrong? Did you see how it's jerking around? Jump off. Doesn't want to jump off. Okay then. That just means the diff is functioning properly. This ain't a welded diff, or any other one that just wouldn't have yielded. Open the gate, I want to go outside. Summer tires. Okay, so there's our lovely hill. I'm going to try and ascend it. Let's see. Oh, and it's still going. And the rear end is kicking out. Awesome, that tells us what now? That both wheels are rotating at once. And that is good. All that's left to do is to make it back down. I'll go ahead and switch the engine off and do some engine braking. I mean, you see what's going on with the weather. Diagonal hang? It just went like this. It's rolling. Oh yeah? Is it off the ground? That's all, oh, and here we go. I am going down. So check this out, this setup actually works. Though I do think we should try a different material. Because we made this out of mild steel that was not subject to any thermal treatment, like forging or whatnot. The point is the material wasn't made any harder. But if we were to use something like chromosil or 45 grade steel, I'd expect it to work beautifully after some thermal treatment. But yeah. It's nice to know that this cheap DIY setup works well. But now I suggest we try another crazy option for making a dirt cheap limited slip differential. Let's go. So look, we are looking into another interesting LSD setup. All of those other ones were mechanical in nature. But this time the idea would be for the slip to be limited not by friction, not by metal contacting metal, but by something else. Something special. By pouring in a certain compound. Right, so it's all actually very simple. In order for all of the parts to have, tough time moving, I mean, the idea here is to limit slip inside this differential. For some parts to push and set others into motion. Well, we see a certain solution that would help us get there and achieve that goal. We start by welding up the housing. Like all the way around, leaving just the filler hole. From there we fill it with some really thick oil. And have you guessed what we're adding to it? Of course, a smidgen of lovely sawdust. Now that should give us some pretty good results. Right, let's get everything ready and go do some testing. Let's go. Check this out, we've added in the sawdust. One might say it came out from our heads, and you might even be right, whatever. But we've suspended a wheel in the air, and what can I tell you? Feels pretty good. But if I were to... I might even set this right away to 6 kilos. And here we go. Won't turn. 10? Let's see. Also won't turn. This is some quality sawdust. Creates quite a bit of resistance. 24? I am super curious. Certainly the car will drop down to the floor. I've maxed out the torque wrench. Oh, okay. Spoke too soon. 26 and it still won't turn. What's the next setting? 33, right? There you go. I broke it, but the wheel hasn't moved. But now let me try driving off the stand. I think it will, I mean, look at this. I'm even struggling doing it with my foot. Let's do this. The moment of truth. Let's go. Nope. Won't budge? What are those nasty noises? I think it's working. The wheel's spinning, holy cow. What sort of stand have you put under it? It's this big. Oh, a humongous one. Well, it does work. And the preload is such that the wheel... the right side is in the air. And I'm on the left driver's side of the car. Which means additional load on this wheel. Doesn't even matter that we're on polished concrete. The wheel is spinning on this surface, so the car won't jump off. Can you open the gate?
Ого-го! Ого-го! Так.
Oh, come on! How does that work, though? This is amazing. How was I able to get all the way up to here? That sawdust actually worked. Holy moly. Someone is worried about their Lexus, huh? Okay, well, it would seem as if the sawdust actually works. Though the way the diff works isn't what I'd call consistent. I mean, you can feel that there's some solid preload, that both wheels are trying to do something. But one of the wheels is getting more grip, and ultimately we are still seeing a bunch of one-tire slip. Isn't that a shame? So to sum things up, and yeah, adding sawdust also did something for us. What sort of tires are you running? No studs, no lockers. Nothing. Now that guy is unable to get up the hill. Meanwhile, with the sawdust additive and on standard Lada all seasons, which are not winter tires by any means. Yeah, those are not winter tires, but I was still able to make it up. If I'd have been carrying a bit more speed, I would have made it all the way out even, I think. So this sort of quasi-LSD, it worked. I should mention that while one wheel was spinning, I could actually feel the torque getting transferred to the other one. The car was moving. And as you all know, ascending that hill on shoddy rubber is pretty much impossible. But this Lada with the differential filled with sawdust was able to make it up. And so there's the experiment, guys. And it was a pretty cool one. Now granted, setting up a limited slip differential on the cheap end in your garage, I mean, I know a lot of people like to do some drifting on the ice in their free time. They maybe even take part in a competition or two. And buying a proper LSD is costly. But alternatively, you can make something like this cheaply and easily. Of course, you'll need to find the right material to make it out of, but from there, just have at it. And that's it for this video. Watch, subscribe, catch you guys later.